When there are more than 2 samples, merely testing the means is not enough. Testing of variances simultaneously is important. Hence, the test applied in such a situation is analysis of variance, in short called as ANOVA, and for detailed explanation of what is ANOVA, we will have to refer to another session, the link for which will be given in the reference material. We are going to consider one way ANOVA for testing more than 2 means, for which we need to state the mathematical model, which is given by Yij equal to the general effect mu, the effect due to the jth treatment and the random error. Here we are assuming that the number of observations in every sample are unequal, that is Nj, but if they are equal, the same test can be used by assuming this Nj to be a constant. The assumptions for validity of ANOVA are assumptions of the F test, since a F test or a F distribution is used to test analysis of variance. The observations that are made are independent. The parent population from which our sample is drawn is normal, and the mean is mu and variance is known to be sigma square. The various effects are additive in nature, and the error term Eij of the mathematical model follows independent normal distribution with mean 0 and the same variance sigma square. The hypothesis here will be testing the means or equality of means rather for V samples H0 mu1 equal to mu2 equal to mu3 up to mu V, and H1 will be at least one of the mean is not equal and it is different. At times H1 is also defined as not H0. The test is at level of significance alpha, and these are the formulae for calculating the various sum of squares for the ANOVA table. Since we are comparing the variances as well, the test statistic here has to be obtained from what is called as an ANOVA table, which is done with the help of these formulae. We shall see the formulae in detail and the method of calculation in the example, and now let us see how are these formulae to be put into an ANOVA table. And the decision criterion will always be reject H0 if the calculated value is greater than the tabulated value. Consider this ANOVA table. The main components are the between group variation, within group variation and the total variation, for which we calculate the between group sum of square, within group sum of square and total sum of squares. The degrees of freedom for total sum of squares is n minus 1 because the total number of observations is capital N. Since we have V treatments, the degrees of freedom for number of groups is V minus 1, and the within sum of squares, the degrees of freedom of within group is obtained by subtraction of between group from the total. Then the mean sum of square is obtained by dividing the between sum of squares by its degree of freedom and within sum of squares by its degree of freedom, and the F ratio is calculated as the ratio of between mean sum of square and within mean sum of square. The example for this is, can we conclude at 5% level of significance that there are differences in the number of jobs between the 3 streams if the number of job offers for students of management in 3 different streams in 4 rounds of placement is studied from the following table. An F distribution has 2 sets of degrees of freedom, one for the numerator which is the between group sum of squares and one for the denominator which is the within group sum of squares. So, the given value of table here, which can also be verified for 2 degrees of freedom of numerator and 9 degrees of freedom of denominator, is 4.26. We have been given the data of number of placements taking place for students of finance, marketing and HR in 4 different rounds of placement, and the hypothesis to be tested is irrespective of the stream in which students are studying, the placements are equally offered. Let mu1 be the mean number of jobs offered to the finance students, mu2 be the mean number of jobs offered to the marketing students, and mu3 be the mean number of jobs offered to the HR students. The hypothesis to be tested is H0 mu1 equal to mu2 equal to mu3 against the alternative not H0, that is either of the 3 means is unequal. The level of significance mentioned is 5%. Now, for this data, we need to calculate the various sum of squares required for the ANOVA table. We have 4 rounds of placement, that is 4 observations in each group, and we have 3 groups, the 3 streams of management students. So, the total number of observations that we have is 12. The first quantity that we need to calculate is the correction factor CF, which is given as square of sum of all the 12 observations divided by 12. So, if I add all the observations, square it and divide by 12, the value is 168.75. In order to calculate between sum of squares, we need Tij square, that is 9 which is the total of 3, 1, 4 and 1, 13 which is the total of 1, 5, 3, 4 and 23 which is the total of 8, 5, 4, 6. The between sum of squares can be calculated as summation Tij square upon n minus the correction factor, that is 9 square 81 plus 13 square 169 plus 23 square 529 divided by 4 minus 168.75. Now, we divide by 4 because in order to obtain the totals 9, 13 and 23, we have summed up 4 observations each. Hence, the value of between sum of squares turns out to be 26. The total sum of squares is calculated as summation Yij whole square minus the correction factor. That is, we need to square each observation of the table, that is all the 12 observations, and then subtract the correction factor from it, which is 3 square 9, 1 square, 4 square, 1 square and so on up to 6 square minus 168, which will be 50.25. The within sum of squares is obtained as a difference between total sum of squares and between sum of squares, which turns out to be 24.25. Now, we construct the ANOVA table for the given problem. The blank or the skeleton ANOVA table will be 3 sources between group, within group total, sum of squares, degrees of freedom, mean sum of squares, F ratio or calculated value of F, and the table or critical value of F. We had obtained the values of total sum of squares as 50.25, 26 for between sum of squares, and by subtraction we get 24.25 for within sum of squares. The degrees of freedom are 11, 2 and by difference we get 9. Hence, the mean sum of squares will be 26 divided by 2, 13 for between sum of squares. Within group it will be 24.25 divided by degrees of freedom 9, that is 2.69, and the F ratio will be 13 divided by 2.69, that is 4.833. The table value is 4.26 for F table from the standard tables. Now, since 4.833 is greater than 4.26, we reject H0 at 5% level of significance for the given sample. Hence, the conclusion will be the differences in number of job offers are significant for the 3 streams. In this video, we have seen different situations under which various tests of hypothesis for mean can be applied. Thank you.